I'm a Dublin teacher living in India, offering low-cost online tuition for the new Project Maths Leaving Certificate and Junior Certificate higher levels. Today I'm going to talk about the derivative. You don't have to be Irish for this to be of interest to you. Since the introduction of Project Maths, calculus takes two easy questions on paper 1, comprising 16% of the paper. A lot of people have trouble with the idea of a derivative. In fact, once you know the idea of a slope m of a straight line, the derivative is just an extension of this idea, except applied to a general curve. Remember the junior certificate definition of the slope m, y2 minus y1 over x2 minus x1. We put x1 equal to x, x2 equal to x plus h, and we get for our value m, fx plus h minus fx over h. Now let's apply this definition to a straight line. We've taken two values of h equal to 4 and h equal to 2, and as you can see in both cases the slope of the straight line is the same. Now let's apply our general definition to a curve y equals fx. In this case the slope m is different for the two values of h. Now let's see what happens as h goes to 0. H is getting smaller and smaller. And as h goes to 0, the line approaches the tangent to the curve. And in fact, this is the geometric idea of the derivative, the tangent to the curve at the point. Now let's see what it is algebraically. Algebraically, it's called dy dx, or f dash x, and it's the limit as h goes to 0 of this ratio, fx plus h minus fx to h. It so happens for any continuous function fx, as h approaches 0, this ratio approaches a constant value, depending only on the initial value x. And this is defined to be the derivative of the function fx. By applying the algebraic definition and some clever algebra, it's possible to calculate the derivative for the following functions. Most of these are listed in your formulae and tables. Now we see why it's called a calculus. It's a system of calculation of derivatives for all types of continuous functions. But what use is this idea of a derivative? First, to calculate the maximum or minimum value of a function. Note that at a maximum or minimum, the slope of the tangent is 0. That is, the line is parallel to the x-axis. So to get the x value of a maximum or a minimum, we just put the derivative equal to 0. So here dy dx is 2x minus 8, and it equals 0 at x equal to 4, and x equal to 4 gives it our minimum. Similarly, dy dx is minus 2x plus 6, and that equals 0 when x equals 3 for our maximum. The second use of the derivative is to calculate the rate of change in, for example, a distance time graph. The derivative gives the instantaneous rate of change. That is, the instantaneous speed. So the tangent to the curve gives the speed in kilometers per hour. As I say, I'm a teacher living in India. Because labour costs are so low here, I'm able to offer online tuition at the rate of €15 per hour with a free half-hour's introductory session. I'm with you throughout the session. Feel free to contact me via email anytime or 5 to 6 p.m. on my telephone or Skype number.